Let's start NMR spectroscopy. NMR. Today our topic is NMR spectroscopy. First of all, we see the basics of the NMR spectroscopy. What's the principle and the variety of the nuclei? Let's start. What is spectroscopy? First of all, we should explain spectroscopy. Then we see NMR spectroscopy, and then so on. Let's start spectroscopy. Study of interaction of EMR, electromagnetic radiation, with matter. Spectroscopy basically is the study of the interaction of EMR with matter, which may result in absorptions, transmissions, emission, reflection, or and rotation of electromagnetic radiations. These are the basics of basic definition of spectroscopy, and we move to the nuclear magnetic resonance spectroscopy, most commonly known as NMR spectroscopy, which is defined as spectroscopic techniques which is based on the absorption of electromagnetic radiation in the radio frequency region from 4 to 900 megahertz by nuclei of atoms. This is the NMR spectroscopy. Proton NMR spectroscopy, most powerful tool for the elucidation the number of hydrogen or proton in a compound. In NMR spectroscopy, we must show the number of hydrogen or proton in a compound. Spectroscopy. What is the main function of the spectroscopy? Determine the physical and the chemical properties of the atom or molecules in which they contain and provide detailed information about structure, dynamics, reaction rate, chemical environment of molecules. So basically we study are the spectroscopy and spectroscopy. What is the basic functions of the spectroscopy? Why spectroscopy are studying? So a spectroscopy provide these type of the information, means physical and chemical property of the atom or molecules, and also provide structures information about the structures, dynamics, reaction rate, and chemical environment of molecules which are under studies. Variety of the nucleus. Let's start, see the varieties of nucleus. Hydrogen 1 hydrogen, 15 N 13 carbon, 19 F, 31 P. These are the nuclei, variety of nuclei that are come under the spectroscopy, that must be studied as a spectroscopy. Means its signal can be detected. What is the let's move the theories of NMR. Spin quantum number I, represented by I, is related to the atomic and mass number of molecule. In spectroscopy, we basically studies, especially in NMR spectroscopy, spin quantum number is the fundamental character in NMR spectroscopies. These are the table I, Z, A. I is the spin quantum number, Z is the atomic number, and A is the atomic mass. Half integer, if half integer, and this is the odd, and this one is also, then they show 1/2 spin quantum, and even half this odd, and even then this is the example of 13 carbon. And integer, if spin quantum number is integer and this Z, E and A is odd, then 2 hydrogen and 1. This is the if integer 0, then even and even carbon 13 which cannot detect is 0. Element with either odd mass or odd atomic number have property of nuclear spin. This is the example of hydrogen. If we hydrogen atomic spin quantum number of hydrogen. Spin quantum number of hydrogen is represented by I, which is 1/2. So the possible orientation, if we apply the magnetic field to the nuclei of one hydrogen, then the possible type of the orientation is this is minus 1 over 2 spin state, and this is the positive 1 over 2 spin state, and the formula that is used to find out the spin quantum number is 2i plus 1. This is the formula. This is all about the spectroscopy, and it's our first lecture. This is the basically the introductions and introduction of spectroscopy. Then we see the NMR definition, and then we see the what is spectroscopy functions, and these are the variety of nucleus. This is the theory, and then we start the principle of NMR spectroscopy. Thank you.